Hi, fifth grade. Well, we're moving right along here. And our first problem today, we've got 900ths times 7 thousandths. So we're going to think of this basically as 9 times 7. And this is going to sound very familiar. We're going to get into some 3-digit factors today when we multiply by 3-digit factors, but this is going to be pretty much the same as 5.7. So once again, in this particular problem, we're going to think 9 times 7. Well, 9 times 7 is 63. So then I just have to remember how many ever digits come after the decimal in the problem. That's how many digits come after the decimal in the answer. Well, there are 1, 2, 3, 4, 5 digits that come after a decimal in the problem. So I need 5. But remember, since I have 2 here, I'm going to count backwards. 1, 2, 3, 4, 5. And I'm going to fill in the rest of the spots with zeros. And that's actually going to end up being 6300 thousandths, 0.00063. This one here, same thing, 6 times 2. 6 times 2 is 12. But I have 1, 2, 3, 4 digits that come after the decimal in the problem. So I need 1, 2, 3, 4 digits that come after the decimal in my product or in my answer. So I end up with 0.0012 or 12 ten thousandths. This one's no different. I'm just going to think 8 times 6. Well, 8 times 6 is 48 the last time I checked. So 1, 2, 3, 4, 5, 6 digits come after the decimal in the problem. So I need 1, 2, 3, 4, 5, 6 digits to come after my decimal in the product. Decimal 0.000048, or 48 millionths is what that would work out to be. All right, so here we go. 1 and 28 hundredths times 6 tenths. Decimals do not have to be lined up in multiplication. We've been through that. I'm going to do this just like 128 times 6. 6 times 8 is 48. Put the 8 down. Carry the 4. 6 times 2 is 12. Plus the 4 is 16. Put the 6 down. Carry the 1. 6 times 1 is 6. Plus the 1 is 7. How many ever digits come after the decimal in the problem? That's how many digits need to come after the decimal in my answer. I have 2 digits that come after the decimal here. I have 1 digit that comes after the decimal there. Remember, after the decimal means to the right of the decimal. So that gives me a total of 1, 2, 3. So I go 1, 2, 3. My decimal needs to go right there, 768 thousandths. Moving right along, all right, this has this 0 here, so we're still going to think of this as 232 times 4. We'll remind ourselves that 0 here momentarily. 4 times 2 is 8. 4 times 3 is 12. Put the 2 down, carry the 1. 4 times 2 is 8, plus the 1 is 9. Now remember, I could put a 0 here, so everything lines up with my 0, then do 0 times 2 is 0, 0 times 3 is 0, 0 times 2 is 0. But all I'm going to do is end up with a row of zeros here. That's not going to change any of my adding, because when I add 0 to something, nothing changes. Okay, if you have 2 chocolate chip cookies and I give you 0 chocolate chip cookies, you still just have 2 chocolate chip cookies. I have not helped you at all by giving you 0 chocolate chip cookies. Okay, so I can go straight now to thinking, okay, I have 1, 2, 3, 4 digits that come after a decimal in my problem. Okay, so I'm going to need 1, 2, 3, 4 digits that come after a decimal in my product. And I end up with 928 ten thousandths. Sometimes you're going to have to add an extra 0 in there. All right, we have a couple more to look at. 6 and 7 tenths times 5 and 6 tenths. Well, I'm going to think 6 times 7. Well, 6 times 7 is 42. So I'm going to put the 2 down, carry the 4. 6 times 6 is 36. Plus the 4 is 40. Going to put a 0 down, so everything lines up with my 5. 5 times 7 is 35. Put the 5 down, carry the 3. 5 times 6 is 30, plus the 3, 33. I now have to add these two numbers. 2 plus nothing is 2. 0 plus 5 is 5. 4 plus 3 is 7. Nothing plus 3 is 3. Now, how many ever digits come after the decimal in the problem? That's how many digits need to come after the decimal in my answer or product. The 7 and the 6 come after the decimal in the problem. That's 2 numbers. So I need to go 1, 2. My decimal goes right there. 37 and 52 hundredths. One more for today's video. Once again, decimals do not need to be lined up. I'm just going to do this like 893 times 727. 7 times 3 is 21. Put the 1 down, carry the 2. 7 times 9 is 63. Plus the 2, 65. Put the 5 down, carry the 6. 7 times 8, 56. Plus the 6, 62. Fifth graders, you see the importance of knowing your multiplication tables. This is going to take you a long time if we are not solid with our multiplication tables. I need to put a 0 here so everything lines up with my 2. 2 times 3, 6. 2 times 9 is 18. Put the 8 down, carry the 1. You'll notice the importance of crossing numbers off so I don't get confused. I used the 6 already. I don't want to accidentally use it again when I should be using the 1. 2 times 8 is 16, plus the 1, 17. Now I have to put 2 zeros, so everything lines up with my 7. 7 times 3 is 21. Put the 1 down, carry the 2. 7 times 9, 63. Plus the 2, 65. Put the 5 down, carry the 6. 7 times 8, 56. Plus the 6, 62. That makes sense because when I had the 7 before, I got the 6,251. When I had the 7 again, 6,251, but now with the zeros. So I'm feeling pretty confident about that. Now I have to add all 3 of these numbers. 1, 0, and 0 make 1. 5 plus 6 is 11, plus 0 is still 11. Put the 1 down, carry the 1. 1 plus 2 is 3, plus 8 is 11, plus 1 is 12. Put the 2 down, carry the 1. 1 plus 6 is 7, plus 7 more is 14, plus 5 is 19. Put the 9 down, carry the 1. 1 plus 1 is 2, plus 2 is 4. Nothing in 6 makes 6. Don't forget to put your decimal. How many ever digits come after the decimal in the problem? That's how many digits need to come after the decimal in the answer. In this first number, the 9 and the 3 come after the decimal. That's 2 numbers. In this number, the 7 comes after the decimal. That gives me a total of 1, 2, 3. So I'm going to come here. I'm going to count backwards. 1, 2, 3. 649 and 211 thousandths. All right. We have one more lesson in Chapter 5. It's been a marathon here in Chapter 5, 5th grade, but we'll get through. All right. Talk to you later. Bye.